Park assist systems are now standard in 85% of new vehicles as of 2024. These sophisticated systems integrate multiple sensor technologies to help drivers park safely and accurately. Modern park assist systems combine three main sensor types: ultrasonic sensors for close range detection, radar sensors for medium range scanning, and camera based systems for visual processing. When park assist systems fail, there are four primary categories of problems. Understanding these categories helps you diagnose issues systematically and efficiently. The first step in diagnosing park assist problems is a thorough visual inspection. Start by examining all sensors around your vehicle for physical damage, dirt buildup, or ice accumulation. Next, inspect the wiring harnesses for any signs of damage or corrosion. Pay special attention to connections near the sensors and check that all fuses are intact. After visual inspection, perform a basic functionality test. Activate the park assist system in a safe environment and test it at low speeds between 3 and 5 miles per hour. Monitor for consistent error messages. These initial checks will help you identify the most common park assist problems. If basic inspection and testing don't resolve the issue, more advanced diagnostic procedures may be needed. When initial checks don't resolve park assist errors, advanced diagnostic procedures are required. We'll walk through systematic testing and repair methods used by professional technicians. The first step in advanced diagnostics is using an OBD2 scanner to read error codes from the vehicle's computer system. This provides specific information about what components are malfunctioning. Common park assist error codes include P0C55 for general park assist malfunctions, B1342 for sensor circuit problems, and U0415 for communication errors between modules. Next, we test individual sensor voltages using a digital multimeter. Park assist sensors typically operate at 5 volts, and deviations from this value indicate sensor problems. Professional technicians use oscilloscopes to analyze signal patterns from sensors. This reveals intermittent problems that basic voltage testing might miss. For basic repairs, start with sensor cleaning using appropriate solutions. Avoid harsh chemicals that could damage sensor housings. Fuse inspection is critical. Park assist systems typically use 10 to 20 amp fuses. A blown fuse often indicates an underlying electrical problem. When basic repairs fail, advanced procedures are required. These include wiring harness repair, sensor replacement, and control module programming. ECU replacement requires specialized programming software. Service programming systems, like those shown here, are used to configure new control modules with vehicle-specific parameters. The key to successful park assist repair is systematic diagnosis. Start with error codes, test voltages, perform basic repairs first, then advance to component replacement only when necessary. This approach ensures efficient repairs and prevents unnecessary part replacement.